Hello and welcome back. We're talking about implication here in our logic unit, section 15E from our IB Math Studies textbook. As you can see, an implicative statement is a compound statement that can be formed using if-then. So we have two statements here. It is raining. I will get wet. This is our P, this is our Q. Connect them together with if-then, and we have if it is raining, then I will get wet. That's an implicative statement. Notice how we write it, the P and the Q connected with this arrow going from the P to the Q. Pretty straightforward, no big deal, right? So let's move on to the truth table. A truth table, in this case, is only false when the first thing, P, called the antecedent, is true, and the second thing, Q, called the consequent, is false. So, if this is true, oh darn, let's see here, let me get my pens, there we go. If this is true, and this is true, then of course, P leading to Q would be true, right? If this is true and this is false, then we have a problem, right? Then we have, this is true, this is false. P doesn't lead to Q, so the implicative statement is false. Now if we have false and true, this is the tricky one, because a lot of students would say this would be false, but in fact, this is true. And the way to remember it is the first thing is false, so you don't necessarily know if the first thing leads to the second, because the first thing's false, so you can't really tell. So you give it the benefit of the doubt, and you say it's true. And then of course, if it's false, then you really don't know, so you give it the benefit of the doubt, so it's true. So the bottom line is that it's only false when the first thing is true and the second thing is false. So true, false leads to the implicative statement being false. Okay? Now, if we have something called equivalence, okay, it's like an implicative statement, but it can go both ways. Two statements are equivalent if one implies the other, and vice versa. It can be phrased using if and only if, also, which is IFF as we write it down. Because again, mathematicians are lazy, we like to abbreviate. Notice that the arrow goes both ways. You can go from P to Q and from Q to P. So Brian is Kelly's brother if and only if Kelly is Brian's sister. Okay? So it's only true if it's true going both ways, and in this case, it is. So, let's fill this in here. If this is true and this is true, can it go both ways? P leads to Q, yes, and Q leads to P, yes. It's true for both, right? Now, can you fill in the rest, the last 3 lines of this truth table before I do? Pause the video and give it a shot. Okay, we're back. So, let's say P is true, Q is false. Now remember, up here we said that a truth table for an implicative statement is only false when P is true and Q is false. So, in this case, this is like an implicative statement but going both ways. So, true and then false. So this is got to be false because P doesn't lead to Q, right? Now let's try this one. This is false and this is true. If you haven't filled this in and you want to rethink your idea, go ahead and pause it. Let's see. Okay, going this way, P leads to Q. Well, P is false and this is true, so we want to give it the benefit of the doubt, so it would be Q. But we have to go the other way because the arrow goes the other way. We have to go from Q to P. So if this is true, leads to false, then it's definitely false. Alrighty, and then finally here we have false, false, right? So if it's false and it leads to a false, we give it the benefit of the doubt and we say it's true. Same thing going the other way. So it's true here. I hope you learned a thing or two. We'll see you next time. Toodles.